the battery electrolysis experiment is a really nice, simple way of generating some hydrogen gas and oxygen gas quickly and demonstrating their properties to students. But nowadays, from a sustainability perspective, I really like talking about hydrogen's role in our future sustainable energy needs. Sometimes you hear about colors of hydrogen, green hydrogen, pink hydrogen, brown hydrogen. But it's a really nice way of connecting that with a really super simple practical activity. I was first taught about this experiment by the legendary Professor Zuriati Zakaria from Malaysia, who told me about an experiment that had been done by a network of young chemists. And I simply thought, well, we have to do it. This is fantastic. It essentially works as this. You get a little plastic cup like this, and you need to put two little holes in the bottom. A simple way to do that would be with some brass tacks. So some metal tacks. It's really important that the tacks do not have any plastic covering because you want a good metal connection there. And just so they don't leak, we use a little bit of blue tack. You've seen blue tack, you'll find it in, probably office stores. Things just stick posters up on the wall. And we sort of put the blue tack between the tack and push through. And you need two good electrodes there. You want them to spaced out about the same distance as you would on a 9-volt battery. So you've seen those 9-volt batteries, those square rectangular ones. They've got two electrodes on the top. And it's really as simple as this. You're going to fill this cup up with some potassium hydroxide. We do need an electrolyte in our hydrogen electrolysis. So we're going to have some potassium hydroxide. It would work with some sodium hydroxide, though we found from experience potassium hydroxide seems to work better. And then you're going to get two test tubes. You're going to fill those two test tubes up with all the way to the top with the same potassium hydroxide solution. You're going to put your finger, whatever's comfortable for you, I wear gloves for this, put your finger on top, and then you're going to invert it over and so the mouth goes underneath the level of the solution in the cup. And then let your finger go. And so you've basically not allowed any air bubbles in. You do it twice with the second one. And now you're ready to go. You've got your two little test tubes. They're going to capture the gas upside down, completely filled upside down inside the cup. So then when you're ready, you're going to get your 9-volt battery and you're going to sit it on top of the 9-volt battery. It's really as simple as that. You'll start to see straight away a huge amount of gas being generated on both electrodes. One will appear to be generating more. And you'll notice, the students would notice after a couple of minutes that in one of the test tubes, there's considerably more being generated. In fact, 2 to 1. And so you can talk about sort of 2 moles of hydrogen being generated for every 1 mole of oxygen gas in this chemical reaction. After a while, it takes, I really like, we're not doing anything that isn't just a simple voltmeter, but because it's small scale, because we've made everything smaller here, the tubes will fill up a lot quicker. And particularly if you've got some batteries that haven't been used that much, you'll get a nice current through and you'll start to fill up that tube. When you're about 2/3 the way through, you'll notice the tube starts bobbling a bit because it's really full of gas. And so that's when it's time to lift it out. Now, you could put a stopper in it or you can put your finger on it, but you want to just quickly let all of the liquid drain out. It'll happen straight away. And then quickly put your finger on it or a stopper or whatever you want to put, because we really want to keep as much of the gas in those. So do one at a time, take one out, stopper it, put your finger on it, whatever you're going to do. Now, there's 2 tests you can do here because, at the moment, we've just got some colourless gases in our tubes. We want to test what they are. Now, maybe you've had a conversation with your students that, the one that generated more, could that be? It's hydrogen. But you could test for it. So a popular test done with, you've probably done it yourself in other contexts, the pop test. Get a match, light it, and then when you're ready, lift your finger off and stick the tune. And hopefully you'll get a nice pop sound. Sometimes you get a really nice high pitch, sometimes it's more of a, but you get a pop. And you can go, oh, well, that confirms the presence of hydrogen gas because the hydrogen quickly combusted in the presence of the flame. For the other one, again, the one that didn't generate as much gas, about half, and lift it out. And with this one, you could do the pop test, but it won't show anything. So what you do instead is, I guess we call it a burnt flint test. Take a piece of wood or flint, light it on fire, flush it out so the flame goes out. So it's just embers, and then stick that, when you're ready, finger off into the tube, and you'll notice that the embers sort of glow more, as almost as if the presence of extra oxygen is causing that thing to burn more. And so that is our confirmatory test for the presence of oxygen gas. That's it, really. The rest of it, the waste can just go down the sink. It's we use about 0.5 molar, and you can probably do it even less, so it's relatively harmless. But gloves are good because you might get a bit sticky hands. I really love this one because it's really super simple. It works really quickly, and it's a great one to connect with hydrogen's role in a sustainable future.